Today we are going over point slope form. Up until this point in my videos, we have been using the slope intercept form. This gives us an equation where we have our slope and our y-intercept value as a part of the equation. In today's lesson, we are going to be using any given point and the slope to create the equation. This starts using more of the subscript value 1 in the equation. If we break down all the pieces that are involved, that also let us know when we're going to use this, is that we have the slope still, as well as an x value of the point that the line passes through, and the y value of the point the line passes through. The reason why it's a 1 is because it is the first point that we have established as part of the function. The way this is similar to our slope intercept form is whenever we have this set up, we can simply add y1 to both sides, moving it over, as seen here. And when we plug in our values of, say, the slope intercept, or I'm sorry, the intercept value, this becomes 0, which cancels out, still leaving us m times our x. And then whatever our intercept value was remains behind as the actual value. When we have the negative value, the negative y1, when we substitute in values. So in this case, when we substitute in this negative 2, it is going to show as a positive 2. And our 9, when substituted in, is going to show a negative 9. This is showing the opposite of what the values actually are. Most people end up getting confused with that. That's why we write the equation down first, so we can see, we can have a visual understanding that we are showing the opposite of what's actually being shown. So our negative 2 being our y1 replaces to be a positive 2. Our 9 now shows as a negative 9. There we go. Shows as a negative 9. And that is substituting in the values. Along with that is the slope, which is also introduced directly in our example's situation. After substituting in our values, we can simplify this expression to start the process to turn this into slope-intercept form. We would like to distribute. Which will leave us with 1/3 x for our first multiplying, and our second product will be a negative 3. We didn't do anything with our y plus 2, the expression on the left, so we leave it as such. And this is using the distribute property. The last step here, in order to solve for y, we have to get rid of this positive 2. And the way we do that is we subtract 2 from both sides. Subtracting 2 allows us to combine these like terms so they cancel out. And then on the right expression, we can combine the negative 3 and the negative 2, which would become our y-intercept value of a negative 5. Now to show this on a graph, we can actually start from our point slope setup by going to our location, negative, our 9, -2, marking it so I don't accidentally go to the wrong location. And now if I follow this slope of 1/3, that means I would go up 1 and over 3, which would remove me from the graph. So I need to go the opposite direction to stay on the graph, going down 1 and to the left 3. Now we want more than 2 points so that I can draw the line a little bit smoother. But as long as you have a straight edge, you can use these 2 points to continue through all the other points. And one more just to show that my y-intercept value is in fact the -5, 0, -5. We have no limits to this, so that means that this is going to be a continuous function. That means it includes every value in between the points, not just the points that I plotted. And then the arrows show that it can continue on in both directions. If I wanted to, I can go down 1 over 3 again to get another point place and extend the line even further. So with this being said, I can use the point slope formula or point slope form to either plot it directly to the graph, or if I need to change it into something more comfortable with what we've been dealing with for a while now, I can solve the literal equation for y, which would give me the slope intercept form.